Pressure can be expressed through many formulas, the basis of each being the ideal gas law and the combined gas law. The combined gas law is P1 V1 over T1 equals P2 V2 over T2. The subscripts of 1 and 2 represent either the initial or final states of these variables. P stands for pressure, V stands for volume, and T stands for temperature, which must always be in kelvins. The ideal gas law is PV equals nRT. The P stands for pressure, V stands for volume, N stands for number of moles, R stands for the number 0.0821, and T stands for temperature, once again, which has to be in kelvins. When there is a low amount of pressure, the particles inside of an object, for example, a balloon, are able to move around a lot more and will have fewer collisions inside of said object. For a balloon, this also means that the particles will hit the wall of the balloon a lot less because there's more space available for the particles to roam. However, if the pressure is high, then the particles will have less space to roam and will collide with each other and hit the walls of the balloons a lot more. When expressing pressure in formulas and also in data, it's important to remember to use the correct units. Atmospheres, or ATM, are one of the more commonly used units for pressure. However, other units are also commonly used, so it's important to know what the conversions are between each unit. 1 ATM is equal to 101 kPa, 760 millimeters of mercury, 14.7 psi, and 76 centimeters mercury. For temperature, the same goes. The unit kelvins is always used, so when you're given degrees Celsius, you're going to need to change it. 0 degrees Celsius equates to 273 kelvins, and that is the basis of the conversion for temperature. To find out the actual amount of kelvins the temperature is, simply add the given temperature to 273 kelvins to find your result. Boyle's law focuses on the relationship between volume and pressure. When volume increases, pressure decreases. This is known as an inverse relationship. An inverse relationship is when one element increases or decreases while the other one decreases or increases. Basically, the elements do the opposite of each other. This is in contrast to a direct relationship, where one element increases or decreases and the other follows in suit. The mathematical formula which is used to express Boyle's law is a variant of the combined gas law. For Boyle's law, you can shorten up the combined gas law by making it P1 V1 equals P2 V2. Now, why does volume increase when pressure decreases? Volume increases when pressure decreases because with a large amount of space comes more room for particles to roam. This means the particles collide way less than they would if the volume decreased. On the other hand, if volume is decreased, there is way less space than if the volume was increased, meaning there's less space for particles to move around. With a smaller space comes a higher pressure because the particles are more likely to collide. Guy-Lussac's law focuses on the relationship between temperature and pressure. When temperature increases, the pressure also increases. This is known as a direct relationship. The mathematical formula to express Lussac's law is again a variant of the combined gas law. For Lussac's law, you can shorten the combined gas law by making it P1 equals T1 over P2 equals T2. Now, why does pressure increase as temperature increases? The pressure increases as temperature increases because when the temperature is increased in something, the particles move faster compared to when the temperature is decreased. When the particles get heated up, they move a lot faster and have a higher possibility of colliding. This increases the pressure. On the other hand, when the temperature is decreased, the particles move slower and have a lower chance of colliding, meaning the pressure is lowered. Lastly, we have Charles's law. Now, Charles's law is the relationship between volume and temperature. When volume increases, temperature also increases, making it a direct relationship. Now, for the mathematical formula for Charles's law, it is once again a variation of the combined gas law. For Charles's law, you shorten up the combined gas law by making it V1 over T1 equals V2 over T2. Now, when it comes to why volume increases as temperature increases, volume increases when temperature increases because when you heat up the gas particles, the kinetic energy of the particles increases. This makes more space in the object where the gas particles are. When the particles are cooled down, the gas particles lose kinetic energy, making them move slower and the volume of the object they're occupying smaller. And that is all about PVT, pressure, volume, and temperature. Thanks for tuning in.